Hello engineers, welcome back. In this video, we're going to continue practicing the recursion concept using another lead code question. Okay, I hope you're ready. Let's get started. So in this video, we'll solve another easy problem, which is power of 4. Let's see the question and then we'll see the solution. Given an integer n, return true if it is a power of 4, otherwise return false. An integer n is a power of 4 if there exists an integer such that n equal to 4 to the power x. Right? Let's try to understand this. So if there is a number 16, we know that 16 is 4 to the power 2. So we will return true in this case. Let's say there is another number 64. 64 is 4 to the power 3. In this case also we will return true. So what does this mean? It means that 16 can be written as 4 into 4 and 64 can be written as 4 into 4 into 4. 4 into 4 is 16, 16 4, 64. Right? So this can be rewritten in another way, right? This can be written as 16 by 4 equal to 4, right? Since 4 4 16, 4 equals 4. And here as well, this can be rewritten as 64 by 4 equal to 4 into 4. So 1 4 can come here. And then this becomes 16. 16 equal to 4 by 4, 4 into 4. Now we can repeat this operation one more time. This will become 16 by 4 equal to 4. And this is 4. So 4 equals 4. So there is a pattern here. What is the pattern? If we keep on dividing the given number by 4, eventually we should reach 1, right? So if it is 4 equal to 4, then this is same as 4 by 4 equal to 1, right? If the given number is actually a power of 4, then when we keep on dividing it by 4, eventually we should reach 1. Here as well, we will reach 1 equal to 1, right? So that will be our logic. So since we are discussing recursion, we need to think in terms of recursion framework. So what will be the base case? The base case is if we reach 1, then we will return true. Why? Because if we keep on dividing this number and if we eventually reach 1, it means that we have successfully divided the number by 4 each time until we reached 1. So how will we get there? We will do recursion. N by 4. So we are given the value n. So if n is 16, let's say, we will keep on dividing it using n by 4. We are breaking the problem into sub-problems. And eventually we have to reach the base case. So this will be our base case. If we have successfully reached n, if we have successfully reached 1, which means our number is divisible by 4 at every division, which means it is a power of 4. Okay, and we will simply return this. So this is the positive case. What is the negative case? Negative case is when we don't reach, when we don't have a successful division. For example, let's consider the number 28. 28 by 4 will give me 7, but 7 by 4 will give me 3. 3 by 4 will give me 0, and we will never reach 1, right? In this case, we don't need to keep on dividing until we reach 0. At this step itself, I know that this will not be further divisible by 4 because 7 modulus 4 will leave a remainder of 3, right? I can use this concept to check in between the division. If there is a number that is not divisible by 4, then I can stop there. I don't need to check any further. So if n modulo 4 is not equal to 0, return false. So this will be the base case. And of course, we have a combination of recursive case and there is no further calculation required. So we will directly return whatever recursion is giving us. If we have successfully reached 1, we will get true. In between, if we reach a number which is not further divisible by 4, then we can stop there and return false. Okay, let's run it. And it is accepted. So if we submit it, this will fail because we have not seen the special case, which we'll talk about. So this is the special case. N equal to 0. Let's see. If n equal to 0, this condition is not true, right? N is not equal to 1. So we will skip this step. N modulo 4 equal to 0, because 0 divided by 4 will give us 0. So this will not be executed, and it will keep on looping it here. 0 by 4, 0 by 4, 0 by 4. In every step, we will get the value 4, and this has become an infinite loop. So this is a special case. So we will just handle this special case. If n less than 1, then return false. That's it. Now we can submit. So that's it. So let's discuss time complexity. So if this is the code, what are we doing? At every step, we are dividing it by 4, right? This is similar to a divide and conquer technique, right? But we are not dividing by 2. We are dividing it by 4. So if the number is 16, we are dividing it by 4, and this is further getting divided by 4 until we reach 1, right? If there is 64, this will have additional steps, right? So this becomes a log n operation. Whenever we are seeing a repetitive division like this, it is a log n operation. But we are dividing by 4, not by 2. So this becomes a log n to the base 4 operation. So this will be the time complexity. Okay. You can report it in base 4 format, or you can convert it into base 2 and then report that as well. Okay. So that will be the time complexity. So in this question as well, we have practiced the concept of recursion. We have created a base case where we are dividing the big problem into small problem n by 4, and then eventually we will reach the base case, and that is when we will stop and start to return. Okay. So that is it for this video, guys. Thank you so much for watching. Please do leave a like and comment, and don't forget to subscribe to the channel and bookmark the playlist. I will see you in the next one. Cheers.